Welcome guys, today I'm going to be solving this logarithmic equation on board, where we're given that log base 4n of 403 is equal to log base 3n of 45, and the problem is to find n cubed. So it doesn't seem we can do much with this equation in its logarithmic form, so let's say it's all equal to some m and convert it to its exponential form, and maybe then something interesting will appear. So that means, by definition of logarithm, that 4n to the m is equal to 40 root 3, and 3n to the power m is equal to 45. Okay, not bad. See how we have both something to the m is equal to something, and something else to the m is equal to something else different. So I think if we divide 4n to the m by 3n to the m and get some number, we may possibly get some equation which we can easily solve for m. And once we find m, then it's easy to find the n cubed. So let's try that. Doesn't seem like a bad idea. We have 4n to the m over 3n to the m, which is going to equal 4 to the m times n to the m over 3 to the m times n to the m. These n to the m is cancelled, and we get 4m to the over 3 to the m, and that's 4/3 to the m. But remember, we also have these values which were given from these properties, and we get 40 root 3 over 45, which seems to be, what, 5 times 8 or 5 times 9, so just 8 root 3 over 9. Okay, so now see how we have 4/3 to the m is equal to 8 root 3 over 9. So we have to hope that m is some rational power. And I think it is. It leads me to believe here that we have 9, which is 3 squared, as a result of raising 4/3 to some power, that m will have a denominator of 2, and it will be some rational number that's not an integer. And what else could it be? Could it be 5 halves maybe? No, that seems too high. So I think a viable guess for m is going to be 3 halves. If we raise 4/3 to the power 3 halves, will we get this number? Let's check it. If that is true, then we have found m. So let's do that. 4/3 to the 3 halves. That means we're going to be raising to the power 3 and taking the root base 2 of the result. That's going to be square root of 4 cubed over the square root of 3 cubed. That's going to be the square root of 64, which is 8 over the square root of 27. Okay, it resembles something here. Let's try getting rid of that. That's going to be 8 over 3 root 3. Let's rationalize it too. So we get 8 times 3 root 3, so 24 root 3 over 3 root 3 times itself is going to be 9 times 3, which seems to be 27. Oh, and look at that. 24 is 8 times 3, 27 is 9 times 3, and that is in fact 8 root 3 over 9. So that is true. We know that from this guess that m is going to be 3 halves. How nice is that? And I think final thing to do here is go back to our logarithms, our initial equations, and plug in m and see what n cubed is. So yeah, we have 3n to the 3 halves is equal to 45. Okay, what's 3 to the 3 halves? It's going to be 3 cubed root 2. Just did it here. It's going to be root 27 times n to the 3 halves is equal to 45. Okay, so that means n to the 3 halves is going to be 45 over root 27 and we want n cubed, so I think we can just square this, because 3/2 times 2 is in fact 3. So let's square both sides, and we get n cubed is equal to 45 squared over 27. And that's our answer, actually. Let's just now simplify it. How can we do 45 squared over 27? Well, I think I know. Look, it's going to be 5 times 9 times 5 times 9 over 9 times 3 over 9 times 3. Okay, so that's, we can get rid of one of the 9's, or no, even better, look, it's going to be 81 times 25 over 27, and there we go, 81 over 27, that's 3 times 25 is 75. And that is the answer, n cubed is equal to 75. So, yeah, this problem is not that interesting because there's very high chance with more random numbers that m would be irrational and would be impossible to calculate just with a pencil. But numbers turn out to be good in this problem. So that's it. Thanks for watching.